Hello everyone, today I want to share some thoughts on the impact of new semiconductor technology. As a student in computer engineering, I'm constantly learning about how technology evolves. But this new generation of semiconductors feels especially significant. These innovations aren't just technical improvements, they are opening doors for major changes in computing, electric vehicles, automation, and even the future career landscape for computer engineers like me. I'll take some time to dive into these aspects and share my personal reflections on why this is exciting, not just for the industry, but for those of us studying and preparing to work in this field. So, how new semiconductors can advance computing? Starting with computing, the changes we're seeing are pretty incredible. Semiconductors have always been at the heart of computers. But the materials we use for them, mainly silicon, are nearing their physical limits. With the introduction of materials like silicon carbide and gallium nitride, the industry can now create faster, smaller, and more efficient chips. For example, with these materials, processors can run with higher efficiency while handling more data. Let's break that down a bit. Right now, tasks like AI processing or machine learning requires a lot of computing power, which means big servers or even multiple machines working together to analyze complex data. With the new semiconductor, computing devices will handle these heavy loads much faster. Imagine the possibilities in fields like medicine, where faster processing could lead to a quicker diagnosis, or in financial systems, where it could mean more real-time data analysis. These aren't just abstract improvements, they are real changes that can affect people's lives. As a student, this is a huge motivator. Learning about these technologies reminds me that the work we do in computer engineering can have a real impact. It's one thing to hear that our field is important, but seeing how these advancements are making that impact tangible gives my studies a new level of purpose. So, moving on to the electric vehicles and automation, the role of new semiconductors here is just as transformative. EVs or electric vehicles today are already a step forward cleaner transportation, but there are challenges. Many electronic vehicles still have relatively short ranges and take a while to charge. New semiconductors can handle higher voltages with less heat production, which means they can make batteries more efficient. This translates to EVs that go further on a single charge and charge up faster. Let's consider automation, especially in industries where seeing the rise of automated robots or even self-driving cars. These applications require quick decision making and real-time data processing. Traditional chips can struggle with this, especially when handling a lot of data from sensors and making instant calculations. New semiconductors with their enhanced speed and energy efficiency enable faster processing, which makes automation system more responsible and reliable. A self-driving car, for example, needs to detect obstacle or pedestrians in milliseconds to ensure safety. With these new chips, reaction times improve, making an autonomous system not just smarter but safer. When I think about this as a future engineer, I realize that we are going to be working with technology that isn't just faster, it's fundamentally better suited to the demand of a modern world. We're talking about technology that could make our cities greener and our factories more efficient. This makes me even more committed to learning about sustainable tech solutions as it shows how our work can contribute to a more environmentally friendly future. Advantages over traditional semiconductors that now let's look at the advantages of these new semiconductors compared to the two traditional ones. We already know that the silicon-based semiconductors have served us well for decades, but they come with limitations. For instance, silicon-based chips tend to overheat if they're put under too much stress. That's why we need elaborate cooling system in many electronic devices, especially high-performance computers. Now, materials like silicon carbide can withstand higher temperatures and don't require as much cooling. This advantage might seem small at first, but it's actually a big deal. It means that system can be built smaller, more durable, and more energy efficient because they won't need large cooling units. This opens up possibilities in extreme environments like space exploration, where equipment must endure high temperatures, or in industrial settings where machinery runs continuously. To me, this speaks to the importance of adaptability in engineering. New technologies can be intimidating because they come with a learning curve, but understanding the why behind these advancements, the need for materials that are more reliable and efficient, help me to see them as a logical steps forward. Thinking about what all of this means for the future of engineers, especially inspiring. With the shift in semiconductor technology, the demand for engineers who understand these new materials and can work with them will only grow. There's going to be a need for skills beyond just traditional computing knowledge. Engineers will need to understand how material science, thermal management, and energy efficiency as well. I also think that this changes how we need to think about our role as engineers. It's not about to just know the theory. We have to be able to apply it in with the many ways that solve real problems. For instance, if I were to work in electrical vehicles or automation, I'd need to think about how to optimize system to be as energy efficient as possible while still performing at high levels. It's challenging, but it's also an exciting opportunity to be at the forefront of technology that can make a real difference. As a student, it's a bit overwhelming but also motivating, knowing that the industry is moving in this direction pushes me to not just focus on the basics but also curious about emerging technologies. It's exciting to think that as a future computer engineers, we could be the ones helping to design the system that shape tomorrow's tech landscape. I'll be reflecting on this new semiconductor technology has given me a better understanding of where the field of computer engineering is heading. These advancements are about much more than I just faster processor. They're about creating sustainable and interconnected future. From enhancing computers to transforming electrical vehicles and automation, these new materials are allowing us to break down previous limitations and dream even bigger. As a student, it's inspiring to see how what I'm learning now could soon be applied in real-world applications that matter. There's a lot of responsibility that comes with this too, and it's up to us, the upcoming generation of engineers, to not only understand this technology but to use it wisely. This reflection has reminded me that I am not just studying engineering to pass exams or get a job. I'm studying it to be a part of community that constantly working toward innovation.